Now that we've finished the grading, we can begin working on the site utilities. Now these drawings are in the same area as the grading, up towards the front of the drawing set with the civil drawings. And the first ones we're going to look at is the water supply lines. Now we know in order to get water to the site, we have to tap into the main water line close to the road, and we can see that here in the drawing. And then the water supply leads from that through a meter and then to various access points to the building on the site. You have to be able to determine what size pipe is going to the building, where to locate the meter. All that is going to be on this plan. In addition to that, we have a thing called thrust blocks. Now with thrust blocks, you're trying to prevent damage to the pipe by a thing called hammer. Hammer is the force that's created when water is shut off rapidly. And that force can actually break apart joints in a pipe. So whenever you have a joint in a water line, in a large water line, you need to put a thrust block. And that thrust block counteracts that force. The size of the thrust block actually has to be calculated based upon the size of the pipe and the amount of the elbow in the pipe. So we can see an example here, let's say using 8-inch pipe, where you follow the 8-inch pipe. Let's say we have a 45-degree elbow. You come down on the chart and you find the thrust in kips. You have to multiply that thrust times 1,000 for this formula, and then divide that by the soil bearing capacity multiplied times 2,000. That gives you the end area square feet. What's interesting about CAPUS is in the specifications, they actually have a table. You can look up the value. It will come to something slightly different than this calculated value, and you'd have to ask the designer which one you want to use. But it is much easier to look it up in a table than to do this calculation.